I'm going to be walking you through how I've used NiFi data flow to automate picking up data from a remote site, unzipping it, transforming it, and finally performing some basic analytics before displaying it onto a web server. So let me show you this. So this is basically a small application that I have developed to rank IPL T20 players. So the things that it does is it basically downloads from Quicksheet, unpacks a zip file, runs some transformations on the unpacked YAML files, and finally ranks the IPL T20 players. Quicksheet is a cricket based data set. You get data sets for different types of matches. For example, here you have the T20 matches, you have Big Bash League, IPL, NatWest, etc. So let us quickly go through these what I have done. So basically there are two process groups: the download and unpack process group, and the convert and rank IPL T20 batsmen. The download and unpack basically will get the zip file from Quicksheet for any T20 match that your T20 matches or T20 formats you're interested in. Then it will unpack the data, and finally it will save it into a specific folder. And the other half, you have the process and rank T20 process group, which will basically look at a specific folder to see if the files have been unpacked, and once it has been unpacked, it will fetch the files and then it will do a transformation. Here it actually looks at all the YAML files and performs the necessary transformations to get it into the required format for processing of the cricket data. So it will look at all the striker, non-striker, what are the extras which happen each and every over, because it is a over by over data you get in this Quicksheet data format. And then it will finally rank the T20 players. Again, this is, I've done it for T20, but it could be done for any of the T20 formats. And also I would like to mention that I've done a specific flow, but the general pattern can be used as a template for various big data end-to-end flow automation. And I've used the regular file system of Mac, but you could also use it with the actual Hadoop ecosystem. So you could use Hadoop, HDFS, Hive, and PySpark, and all things like that. So let's get started. So after it, so basically after it downloads, it will store the YAML files in this folder, and the transformation processor will basically transform and store it in this particular folder. And once it ranks, it will write it into a text file in a folder, and I have a simple web server based off Node.js, which will constantly keep looking at that text file. Currently it says working because nothing has been done now. So let me start it and show you how this thing happens. So I start both the process groups. So let me go and see if anything has come here. So far nothing has come. So it should start pretty soon. Um, yeah, so it is done now. So now you can see it has started to convert, and I have a concurrency of 8. So basically you will see 8 Python threads actually being spawned every second, which will look at the YAML files and actually start to convert them into the pandas data frame and the CSV file. So if you look at it, 8 different Python threads are actually converting the YAML files in this folder into the appropriate CSV file. So this will keep happening till it actually uh, uh, exhausts all the files in this particular folder. So currently there are a total of 756 YAML files, so each of them have to be converted. So as I said, even though this is being done in Python and regular Mac system, you could do it on HDFS and take into account the parallelism that a big data cluster can afford you by using things like PySpark. Okay, so that is one of the things that we can do. See the multiple process actually processing it concurrently. Then another 21. So all of it has been processed, and now it has been reduced to one because this doesn't have any concurrency, this processor. So now it is just merging all the files together, and then it'll trigger this rank 220 players, which will basically look at all the generated CSV files, the batting details of all the batsmen in different teams, and then it'll do a ranking of the batsmen and pick out the one with the highest average and the highest strike rate. So still, if you look at this, the web server is still saying that still saying that it is working. So the output has not come yet. So it is now actually running. It is doing the ranking. It takes some time. Uh, so this is actually using the normal Python code. So this is basically an execute stream. Both of this and this are really an execute stream command. However, we can actually use PySpark and in the NiFi flow, and if the data itself was large enough that it had to be stored across multiple clusters, then we could actually run PySpark to and take the parallelism advantage of parallelism and be able to generate the results really very fast. In addition, while this pattern is does almost the end-to-end flow for what is typically big data. In this case, the data size is not that large. It is just about, I would say, I've taken IPL T20, which is roughly about 2 megabytes. So it's not a whole lot. But still, it demonstrates some of the key aspects of how to generate an end-to-end flow for big data from ingestion, unzipping, processing transformations, and then doing some analytics. So now again, this it appears that this ranking has almost been done. The queue is still not empty. So let us wait for it. Just for a few more seconds, it should get done. And yeah, I think it is done. Now let us look at whether the results have come. Let me refresh the screen. So there you have it. You have the ranked players. The best highest rank is David Warner with a run average of 37.58 and a strike rate of 1.119, followed by Chris Gale, and then Marsh, and then Kehil Rahul, and Mike Hussey, and Virat Kohli. So you get the complete end-to-end flow starting from the source transformation all the way to analytics done through NiFi automation pipelines. And again, let me quickly stop this. While this was done just for IPL T20, it could be done for any of the T20 matches. And besides, my yorkpy has close to 45 to 50 different functions, and you could use any of these functions as which can be applied. And then, assuming that you have a very nice UI UX using let's say AngularJS or React JS, you could display different charts and a dashboard at the other end. And let us say that you're having daily matches and you want to do an analysis on a regular basis, then we could simply use this automated NiFi pipeline. So this is just a demonstration of how we could do. But typically, while this is an end-to-end pipeline, but the same thing could also be used in the case of a big data situation. So thank you for listening.